All right, this is on pages 9 and 10. We're going to start first with the factors that regulate renin. All right, these are listed in the new book. Number 1, perfusion pressure to the kidney. It's inversely related. So if perfusion pressure goes down, it stimulates. If perfusion pressure goes up, it inhibits. I'll try to go slow through this for those of you who don't have the book. And what we'll do at the end of the night, for those of you who don't have the book, if this is since this is not available in your book, we'll unsync the slides and you'll be able to go back and you can look at any slides that you want to. Second, sympathetic stimulation to the kidney. All right, sympathetics will cause renin release. It's a direct effect on the beta-1 receptor. Third, sodium delivery to the macula densa. Now notice this is not the blood, this is the macula densa, which is part of the nephron. And it's inversely related. So if sodium delivery goes down, it stimulates. If sodium delivery goes up, it inhibits. And it's sodium delivery to the macula densa. So those are our factors regulating renin. Why do we care about renin? Because renin converts angiotensinogen to angiotensin 1. Angiotensin converting enzyme converts angiotensin 1 to angiotensin 2, which is the active form of angiotensin. And angiotensin causes vasoconstriction, but it also causes aldosterone release. So, primary factors regulating aldo, I just call it aldo. I've known aldo for so long. Just instead of aldosterone, I just say aldo. It is stimulated by number 1, angiotensin 2. This is our renin, angiotensin, aldosterone system, RAS. So that's why we care about renin, because renin is an enzyme. It is the rate limiting step in the production of angiotensin 2. Second factor that's going to affect aldo is plasma potassium. Boy, when we get to the endocrine system, please remember this plasma potassium. That's a big thing. 2 things regulate aldo. Angiotensin 2 and potassium. Potassium, directly related. Next, primary factors regulating arginine vasopressin, also known as ADH. ADH. Number 1, it's directly related to plasma osmolarity. So plasma osmolality. This is a negative feedback system. So is the aldosterone system. Next, it's inversely related to blood volume and blood pressure. So if blood volume or blood pressure goes down, vasopressin goes up. Now again, very important negative feedback system. Vasopressin's job, what it does vasoconstrict, but it also causes water reabsorption in the kidney. So it should make good sense. If osmolarity goes up, then I reabsorb water to bring osmolality back down. It's a concentration. One of the themes through all of physiology, particularly as we get to the kidney, you must appreciate concentration. Separate concentration from total mass. Water affects concentration. Second, if blood volume or blood pressure goes down, hey, makes sense. I'm going to release a vasoconstrictor. And I'm going to tell the kidney to hang on to water. Let's bring that volume back. All right, what is the fundamental thing aldo does? What does aldo do? What's the one thing, you just really focused on? What does aldo do? Sodium reabsorption in the kidney. Excellent. Sodium reabsorption in the kidney. But let me ask you this. Am I reabsorbing that sodium just for sodium's sake to try to increase the concentration of sodium, or has it got some other real more important aspect? Asia. Aza. Excellent. Excellent. All right. Water follows. Good. Woodson. Excellent. 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 You know what? I'm going to say this many times. I'm going to say this many times. We regulate sodium to regulate volume. We regulate sodium to regulate volume. Aldosterone causes sodium retention for volume regulation. For volume regulation. That's not necessarily intuitive, but darn is it important. We're going to hammer that. We're going to hit that many times. Okay? So, big players, volume regulation. Aldo, because I regulate sodium to regulate volume. And arginine vasopressin. It is regulating water, so it is regulating volume as well.